doing? All good? All are safe, all are healthy, all are fit? Great. I'm your Mahesh, your physics teacher, and you're watching SMR Online Physics, my YouTube channel. Right? Are you excited about today's class? Then give me a thumbs up, right? Next, we'll study about the principal rays of convex mirrors. Alright, we did everything what we wanted to do for concave mirrors. Hope you have understood very well. So please practice them properly. It's going to be very useful for the next part of this chapter. So before we do that, for convex mirrors, let me tell you the simplest thing. Whatever we did for concave mirrors, the same four principal rays are valid for convex mirrors. Absolutely. So you remember what were those principal rays. So here, make it sure you don't get your diagram wrong. Now I'm going to talk about the convex mirror. Remember students, it is the outer surface of your shining stainless steel spoon. Yes. If you haven't watched my previous video on spherical mirrors, do watch it. The link is given in the descriptions below, right? Okay, this is your convex mirror, the reflecting surface bulging outwards. So everything else remains the same. Get your principal axis right through the middle of it and mark your points P. So since the curvature is on the right hand side, naturally the sphere is going to be finished off on the right side, not on the left side. So natural, the center should be lying on the right side, not to the left. Okay, again you might have noticed that in this case also the spherical mirror's reflecting surface is intentionally facing towards the left. The reason will be very clear in my next lecture. So the midpoint can be chosen approximately as the focus of the convex mirror. Yes. The principal ray number 1 says any ray of light incident on the convex mirror after reflection should be appearing to diverge or appears to diverge from a point on the principal axis. And that point we know very well is the focus of the convex mirror. Clear? Is exactly the same what we did for concave mirrors. In this case, try to understand how to draw the normal. The normal is an imaginary line passing right through the point of incidence and connected to the center of curvature of the mirror. Hope the dotted lines are not confusing you. Please check it once again, okay? So since this arrow indicates this is the incident ray, the angle between the incident ray and the normal is called angle of incidence. The angle between the reflected ray and the normal is called angle of reflection. That's it. So according to the laws of reflection, angle I should be exactly equal to angle of R. That's it. That's your principal ray number 1. Let me show you the second principal ray valid for convex mirrors. I think most of you are already guessing or maybe even have attempted to draw the principal ray number 2 because it's going to be exactly the same what we did for concave mirrors, which obeyed the principle of reversibility of light. Absolutely. So in this case, how it will look like is, suppose you imagine a ray of light, you can just make a mark of it, something like this. Observe it closely. It's not coming this way, right? A ray of light is incident on the mirror in such a way that it is directed towards the focus of the mirror. In such a case, after reflection, the reflected ray emerges parallel to the principal axis. So just scroll down and watch both these diagrams. They both are exactly opposite of each other, according to the principle of reversibility of light. Okay, so just draw your normal. Normal is definitely the same definition, passing right through the point of incidence and connected to the center of curvature of the mirror. So the angle between the incident ray and the normal is angle of incidence. The angle between the normal and the reflected ray is your angle of reflection. So hence in this case also we find angle of I should be equal to angle of R. The first two principal rays of convex mirrors. Please note them and I will show you the next two principal rays. Okay, right. Now let me show you the third and the fourth principal ray. Okay, I hope you're getting my explanation very clear. Okay, Right. The third principal ray, you remember for what we did for the third one in case of concave mirrors? Absolutely the same one, right? Any ray of light, suppose from any direction, if it is incident upon the convex mirror, if the ray is directed towards the center of curvature of the mirror. Please mind it. This ray is not directed towards the focus, it is directed towards the center of curvature. It could have been from the top, it could have been right from the below the principal axis, in whatever possible direction. If it is directed towards the center of curvature, then definitely it's a case of normal incidence. It makes an angle of 90 degrees with the surface. Hence, the reflected ray is going to retrace its own path. Is that clear? So in this case, angle of incidence will be equal to angle of reflection will be equal to 0 degrees, as we saw in case of concave mirror. Right. Now, the last principal ray valid for convex mirror will be something like this. Exactly what we did for concave mirrors. A ray of light incident on the pole of the mirror. It reflects, making equal angles with the principal axis. In this case, it's not a big surprise to see the center of curvature. The line actually passes through the pole, so this principal axis itself will behave like the normal as it did in case of concave mirrors. So this ray is your incident ray, so this angle will be your angle of incidence, and this is your reflected ray, so this angle will be your angle of reflection. So by the laws of reflection, both the angles should measure exactly the same. Okay? So these two, the third and the fourth, and the first and the second, what we did just now, comprises the four principal rays valid for convex mirrors. Hope you're able to understand all the intricacies of geometrical optics, that is principal rays and ray diagrams. Now, my dear students, I'm going to show you how to construct a ray diagram for convex mirrors using the principal rays. How many principal rays we know? Definitely 4 principal rays. Out of the 4, as we did for concave mirrors, we can use any 2 to construct the ray diagram. In this case also, the first position of the object which we will be studying for is an object which is situated extremely far, which we call as the object situated at infinity. Alright? The object being situated at infinity, very, very far, just like the sun in the sky. Too far and too bright a source of object, a luminous source. So that we indicate on the diagram as a large arrow mark, an object which is pretty large in size, but at the same time very, very far away from the mirror. That is how we exactly visualize. So from the objects which are very far away, if a ray of light emits and comes, it always comes like parallel to the principal axis. You can use the principal ray number 1 at least 2 or 4 times above and below the principal axis. That's it. And just follow what you have learned so far. A principal ray which is parallel to the principal axis always reflects off the surface of a mirror in such a way that it diverges away from a point on the principal axis, that is the focus. So here you can see that every principal ray seems like getting reflected off from a very common point. It looks like as if the entire journey of the rays actually started from the focus, but my dear students, please also bear it in the mind, everything what we're drawing behind the mirror is absolutely virtual, because the rays of light cannot pierce through the mirror, as it's very evident. So in case the ray of light is incident along the principal axis, no surprises, this is the case of normal incidence, so it is going to reflect back along the same path. So you can see that the entire reflected beam seems to emerge from this common point. This is actually a virtual point. This point actually is the image of this object which is at infinity. So where is the image forming? Definitely, position of the image, we will say the image forms at the focus F, just like your first ray diagram for concave mirror. What about the size of this image relative to the size of the object? Definitely point size, or you could have also said highly diminished image. Extremely small image is formed at this point. Nature of the image is extremely important to be understood. It is not an image which can be obtained on an opaque screen. Rather, it is a virtual image, as it is evident from the ray diagram. Virtual, but at the same time the image will be upright, what we call as erect image. It is virtual. Again, I'd like to repeat it. The reflected rays do not actually meet anywhere in the future. They seem to be diverging from the point called the focus. So this is a non-actual intersection of the reflected beam. Sorry. This point is called as the virtual intersection. Hence, a virtual image is formed, which is also erect. Please note down this diagram. We will move on to the second and the last possible position to be studied for convex mirror. We will study the second position for convex mirrors. Clear? Now it's pretty easy. In case of convex mirrors, which has a reflecting surface which is bulged outwards, whether the object was at infinity, as we have discussed in position number 1, or even if it comes closer, it has been found practically that the image never grows in size. In simple terms, it never becomes larger or even equal to the size of the object. Alright? And the secret or the scientific reason behind this is the reflecting surface being curved outwards starts capturing much more light from various possible angles, as you can see there, and hence it can show you a wider field of view, but the images become diminished but stay erect. Alright? So hence we call the second position and the last possible position for the study of convex mirrors is stand or place the object anywhere between infinity, that is extreme far, and the closest point of the mirror, that is pole. So between infinity and pole of the mirror, wherever you place it, the characteristic of the image is not going to change. Suppose the object is standing somewhere here, AB. So use any principal ray you wish and construct a ray diagram. You will find that, for example, a ray of light incident parallel to the principal axis will always reflect back in such a way that it seems to diverge away from the focus. Well-known principal ray. Again and again I tell you, for all the concave mirrors positions and convex mirrors positions what we have discussed so far, you are free to choose any 2 or 3 principal rays out of the allotted 4. Clear? But do not go beyond those 4 principal rays. That won't be considered as correct diagrams. At the same time, you could have chosen, suppose, a ray of light incident on the pole of the mirror, and according to the laws of reflection, it has to bounce back, making the equal angles with its normal, in this case the principal axis. So if you notice the reflected ray 1 and reflected ray 2 of the 2 rays what we have chosen so far, you will find that the reflected rays do not intersect, or they do not really look like intersecting even in the future. But an image is formed of this object in the mirror, and that is shown by producing the reflected rays backwards. As I produce it back, I find there is a virtual intersection happening above the principal axis, and that has to be the image of the tip of the object. If the object was A, then this tip will represent A prime. If the foot was B, then this will represent B prime. That's it. Is it clear? So AB is the object, A dash, B dash is our image. So that's it. So very, very important point to be noted down. As you are coming closer and closer and closer to this mirror, the image will always lie between pole and the focus, but will start coming closer and closer to the pole, but never goes beyond the focus of the mirror. So it's always comfortable to write for position of the image. You can say behind the mirror, but I'd like to suggest to you, please remember the image distance in case of convex mirror cannot exceed the focal length of the mirror. So it's good to remember the image is always going to form between pole and the focus, which in fact we keep on saying forms or seems like forming behind the mirror. Size of the image relative to the size of the object will be small in size, okay, smaller in size, or you can say the image is going to be diminished. At the same time, the nature of the image, can you guess it right? Absolutely correct. This has to be a virtual and erect image. So that's it, my students, for today's class. I hope I was very clear in my discussion. Everybody has understood very well how to draw principal rays for concave and convex mirrors. At the same time, I suppose I have really done the best possible to make you understand how to draw the ray diagrams and remember them for a longer period of time. Yes, and you surely have understood real images and the difference with a virtual image. Is that clear? It needs a bit of practice. Persevere with this work, practice it again, stay safe, stay active. See you again in my next class. Till then, goodbye, all the best. Thank you.